Now let us discuss a new part of the kinematics, that is relative motion. Relative is always subtraction. Now the relative term comes between the two objects when the two objects are moving with certain velocities, either in the same direction or in the opposite directions or in any random directions. So the relative motion comes from that. That means with respect to a moving object, another moving object appears to be. So relative, I can say appears or seems to be. Now number one, we can say equations of motion can be used in relative motion, provided the relative acceleration must always be constant. Now let us say an example. Car moving with velocity v, acceleration a, particle is being dropped, p is being dropped. So this is the vehicle. So velocity of particle with respect relative is always subtraction. So, or I can say this is, or I can write velocity of particle with respect to ground is equal to velocity of particle with respect to car plus velocity of car with respect to ground. Velocity of particle with respect to car is 0 plus velocity of car with respect to ground is v. So velocity of particle with respect to ground is equal to v. A relative motion equations are vector equations. Number 3, relative velocity of A with respect to B is defined as velocity of A which appears to be taking B to be at rest. Example, suppose this is A, VA, this is B, VB. So I need to make B to be at rest. So for B to be at rest, I superimpose this VB. Here also I will superimpose with VB. So now B is at rest. A is moving with a speed VA minus VB. So A and B moving in same direction. So VA with respect to B is VA minus VB. All are vectors. Similarly, VB with respect to A is VB minus VA. So I can write VA with respect to B is minus VB with respect to A. Now what happens when A and B are moving in the opposite directions? So I need to make, so A and B moving in opposite direction. So I need to make B to be at rest. So here I write VA, here it is VB. So here it will be VB, here it will be VB. So here B at rest. So A is moving with the speed VA. So I can write here VA with respect to B is VA plus VB. Similarly, VB with respect to A will be same VB plus VA. So when the bodies are moving in the same direction, I can write in this. Relative motion equations can be used in one-dimensional and two-dimensional, but when we are considering motions in 1D, we can avoid the usage of vector algebra. Next is relative motion equations are not applicable for the objects moving with speeds as comparable to the speed of light. Two particles A and B are thrown vertically upwards with velocity 5 meter per second and 10 meter per second. Find separation between them after 1 second. So I will have like A relative will be 0 because for both the bodies G is acting downward, same direction. So relative acceleration is 0. Velocity of B with respect to A is VB minus BA. So this is 10 minus 5 meter per second. So separation between them is nothing but VBA into T. This is 5 into 1, that is 5 meter. Now without using relative motion, you can have like this. SA is UAT minus half GT square. UA is 5 into 1, half into 10 into 1, so 0. SB is 10 into 1, half into 10 into 1, so 5 meter. So SBA is SB minus SA. This is 5 minus 0. Now this is a case where A is moving in the upward direction, B is moving in the horizontal direction. So I want velocity of B with respect to A. So velocity of B with respect to A, all vector equations can be used. So VB is in this direction. Minus BA. Minus BA means I have to consider the negative one. So resultant of this will be in this direction. Similarly, you can have two bodies moving, one body moving, VA moving like this, VB moving like this. Now you can have velocity of VB with respect to A. VB is in this direction, VA will be in this direction minus VA. Again the resultant will be in this way. V square plus V square root over. Now this is the question. At any particular instant, the motion of two particles is as shown. Determine the velocity of approach at shown instant. Whenever we talk about velocity of approach, you just join the two lines, 2 points by a line, irrespective of their orientation. Join the. Now we will resolve all the velocities in the direction of the joined line. Let this angle be theta. So I know tan theta is equal to 3 by 4. Sin theta is 3 by 5. Cos theta is 4 by 5. Now I extend this line. This is theta. This will be 90 minus theta. This one will be 90 minus theta. So this is 5. I extend this line. This is 5 cos 90 minus theta, which is 5 sin theta. Now this is 10. This one will be 10 cos theta. So velocity of approach mod will be 10 cos theta minus 5 sin theta. So 10 into 4 by 5 minus 5 into 3 by 5. 8 minus 3. So we are considering the applications. Motion of vehicle on the surface of Earth, considering Earth's rotational effects. Earth, we consider any point on the Earth is moving with a velocity VE with respect to Earth's center, and velocity of vehicle with respect to Earth is equal to velocity of vehicle minus velocity of E if vehicle is moving from west to east. That means in the direction of Earth's rotational axis. Now V with respect to here is VB plus VE if vehicle is moving opposite to Earth's rotational axis. Now to find the distance of closest approach. Now there are several ways to find out the distance of closest approach. You can take at any instant of time the particles are at certain distances. You can find the distance between the two particles, like I can use by using differentiation, or I can say by using relative motion concept. We can find out by many methods. So we'll explain by a certain problem to find out the distance of closest approach. Two cars are moving west to east and south to north with speeds 20 meter per second and 15 meter per second. A is at 500 meter and B is at 400 meter from point of intersection of crossroads. Find the shortest distance between them. So we will solve this by using relative motion concept, and I'll draw a diagram. So A is moving with a speed of 20 meter per second, is at a distance 500 meters, and this is at a distance of B is at a point of 400 meters. Now relative motion concept means one particle has to be at rest. So velocity of A with respect to B. Now I consider B to be at rest. So B to be at rest means velocity of VB minus velocity of VA. So we'll solve this problem by using relative motion concept by taking any of the moving body to be at rest. So I take B to be at rest. Velocity of A with respect to B is velocity of A minus velocity of B. minus velocity of beam is in this direction. So the relative will be in this direction, the resultant. Now let us say this angle to be theta, and let us say this distance to be x. So I can write here tan theta is equal to Vb by Va. Vb is 15 by 20, 3 by 4 equals to x by 500, or x is equal to 500 into 3 divided by 4. So this becomes 375. So x is 375. So I can find out this distance. Let this distance be E. So EB will be 400 minus 375. So this is becoming 25. So this is theta, this is 90 minus theta. This one will be also 90 minus theta. Now to B, this A is moving in this direction. Now the shortest distance will be obviously the perpendicular distance. So BF is the shortest distance. So shortest distance is BF. So which will be nothing but 90 minus theta. So this will be theta. So which will be nothing but EB cos theta. So EB is 25, cos theta is tan theta, you got 3 by 4. So cos theta will be 4 by 5, 20 meter. So the shortest distance is 20 meter. Next we will solve this by using velocity concept. Like I can draw this diagram. This is moving with a speed of 20 meter per second. This is moving with a speed of 15 meter per second. This is 500 meter. This is here 400 meter. So if I join this line, so let this angle be alpha. This will be 90 minus alpha. So relative motion means shortest distance 0, Va cos alpha plus Vb sin alpha is equal to 0, or Va cos alpha minus Vb sin alpha, or this simple tan alpha minus Va by Vb. Minus Va by Vb means Va is minus 20 by 15 minus 4 by 3. Now at some point the distance is here and B is at here. So again this alpha dash or 90 minus alpha dash will be same. So minus 4 by 3 remains constant. So this distance will be 500 minus 20t. So this one will be 400 minus 15t. Again the alpha remains same. So tan alpha 400 minus 15t divided by 500 minus 20t is equal to minus 4 by 3. So that implies 1200 minus 45t is equal to minus 2000 plus 80t. So this becomes 3200 equals to 80 minus 80 plus 45, 125t, or that implies t is equal to 3200 by 125. So 525. So we divide this, 5 1 is 5, 14 to 128 by 5. So 128 by 5. So OB dash will be 400 minus 15 into 128 by 5, 3. So 400 minus 3 8 24, 2, 3 2 6 to 8, 384, 16. And OA dash is equal to 500 minus 20 into 128 by 5, 4. So A dash B dash 16 square plus 12 square